Okay, optimization problems. 5.3. Optimization problems involve word problems, and optimizing means determining the values of the independent variable so that the values of a function that models a situation can be minimized or maximized. Optimizing means minimizing or maximizing. So, for example, you're to find the first derivative, set it to equal 0, and then use the second derivative test to determine concavity. Let's look at a problem. So here's one from the book. A rumor spreads through population in such a way that T hours after the rumor starts, the percent of people involved in passing it on is given by P at T is equal to some function. What is the highest percent of people involved in spreading the rumor within the first 3 hours? And when does this occur? Well, highest means maximum, folks. So we have to set the derivative of P equal to 0. That means that 0 is equal to 100 times that entire function. The derivative of that entire function. Now, the derivative of that function, let's look carefully, is negative e to the negative t, and then negative 4 times negative, which will make it plus 4, times e to the negative 4t. From there, we can common factor an e to the negative 4t, because remember, we have to pull out the lowest, and this is your lowest, and we result in negative e to the 3t plus 4. When I divide this by e to the negative 4t, it's negative t plus 4t, and that's why we get 3t. And this is going to be gone, so we have these two values that could potentially be 0. E to the negative 4t, we set the first part equal to 0, and the second part equal to 4. Why is it equal to 4? Well, looking here, I get negative e to the 3t is equal to a plus 4 is equal to 0. So I'm going to move this over so I get e to the 3t is equal to 4. Now, the first part, is this possible to equal 0? You know that the e function has a horizontal asymptote at y equals 0. Therefore, it's impossible to equal 0. So we only have to look at e to the 3t is equal to 4. What values of t will that be? Well, take the ln of both sides, folks, and then you find out that t is actually equal to ln 4 over 3. So, now we have to test ln 4 over 3 at the second derivative. The second derivative is equal to, so this is p double prime of t, p double prime of t, and that p double prime of t, we're going to take the derivative of this one here, folks. So the derivative of this is 100 times negative and a negative make positive, e to the negative t. And this will be negative 16, because we're bringing the negative 4 down, negative 16 e to the negative 4t. Well, we test the derivative at that value that we found earlier. So we're testing p double prime at ln 4 over 3. And we find out that p double prime at ln 4 over 3 is going to be less than 0. We just plug in the value, and we find out that that value and the second derivative is less than 0. So that means it concaves down. Because of that, it concaves down at t equals ln 4 over 3. We can prove that, oh yes, folks, it is a maximum. That means it is the highest point we're looking at. You have to prove it's the highest point. Not only do you have to prove it, you have to actually answer the question. Most of the time, students forget to prove it's the highest point. This is critical enough that I want you to remember this. Not only do we have a value, such as this right here, this is our value, we also have proved that for sure this is the maximum value, because we could have multiple points, folks. Anyways, let's moving on. we find that there is a max at t equals ln 4 over 3. So, this means that this is when it occurs. You would find a decimal answer for this, and depending on how many places to round it to, your final answer will have the decimal value to 4 places or less. Alright, next you're to find is what is the highest? Well, you plug in the value p at ln 4 over 3 in the original function. Don't forget that ln 4 over 3 is equal to 1/3 of ln 4. So we're actually going to plug in 1/3 of ln 4. So plug it in, 100 e to the negative 1/3 ln 4 minus e to the negative 4/3 ln 4. And what we're going to do is we pull out the value, so p at 1/3 of ln 4 is equal to 100 times e to the ln 4 of negative 1/3 minus e to the ln 4 of negative 4/3, and then that will result in a value of 100 times 4 to the negative 3rd minus 4 times 4 to the power of negative 4/3. Why is that the case? Well, folks, we talked about this earlier, so we're going to start a new page, and you're going to see where I got that answer from. Let's talk about e to the ln x. E to the ln x, let's say it's equal to function y. Now, we need to bring the x down in order to take a derivative, say. So, y is equal to ln x. I'm now going to take the ln of both sides. So the ln of y is equal to the ln of x times ln of e. Now, ln of e is equal to 1. So this answer is now going to be 1. So that we have ln of y. So again, ln of e is equal to 1. So we have ln of y is equal to ln of x. Well, both sides we've ln'd, both sides we can unln, and we find out that y is equal to the x. So y equals e to the ln x simplifies itself, folks, to y equals x. So we can now take y equals e to the ln of something and automatically make it just x. So back to the previous question, what we have here is that we have 100 times 4 to the negative 1/3 minus 4 to the negative 4/3. Where did that come from? Looking here, it's e to the ln 4 minus e to the ln 4. E to the ln 4 is equal to 4. That's where the 4 came from. With the exponent negative 1/3 minus 4 to the exponent negative 4/3. If we were to simplify this further, let's say you were given in the question, let's say you're in a university where your calculators are not allowed, you can now simplify this expression even further. You would have, let's go back, you would have now 100, and you would have to pull out 4 to the negative 4/3. So 100 over 4 to the negative 4 to the 4/3 on the bottom times, this would be 4 to the power of, now let's look at this, negative 1/3 minus negative 4/3. Negative 1/3 minus negative 4/3 is going to be 3/3, which is 4 to the 1, which is 4, minus 1. And then the resulting answer will be 300 over the cube root of 256. Sorry, folks. And that's what the answer would be. If we were to simplify it just a little bit further, you could get 300 over 4 to the cube root of 4. And we could simplify that even further to get 75 over the cube root of 4. 75 over the cube root of 4 as our final answer. That is this question here simplified to give you this answer. So that would be the maximum value when the p at 1/3 of ln 4. That's your maximum value. All right, that's the end of this video. Folks, take care. Have a good night.